Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P0121 and P0221, indicate issues with the throttle position TP sensors, A and B, respectively, in a Honda Civic 2022 and newer models. The TP sensors are crucial components that monitor the position of the throttle plate, which regulates the engine's air intake. If the signal received by the Powertrain Control Module, PCM, from either of these sensors deviates from predefined threshold values, it triggers these DTCs. The diagnostic procedure includes inspecting the TP sensor's circuitry, the throttle body, and the PCM for faults. Accurate troubleshooting is essential to restore optimal engine performance and ensure emissions compliance. It is important to note that the performance issues indicated by these DTCs may lead to reduced engine power, increased emissions, and potential stalling. In this presentation, we will work through the step-by-step troubleshooting guidance for these codes. DTC P0121 indicates a range or performance issue with the throttle position sensor A, while DTC P0221 pertains to the throttle position sensor B. Both sensors play a vital role in relaying the throttle plate position to the Powertrain Control Module, PCM, which uses this information to optimize air-fuel mixture and engine performance. The TP sensors are integrated within the throttle body assembly, which is situated in the engine compartment, directly connected to the intake manifold. When the throttle plate is adjusted, these sensors send voltage signals to the PCM, reflecting the amount of air entering the engine in real time. If the readings from either sensor fall outside the specified range for a given period, the PCM identifies this abnormality, triggers the corresponding DTC, and stores it in memory for diagnosis. The identification of these codes can significantly assist technicians in determining the underlying issue affecting engine operation. Several factors can lead to the appearance of DTC P0121 and P0221. Firstly, faulty throttle position sensors can produce erroneous voltage readings, thereby sending incorrect data to the PCM. This can occur due to internal electrical failures or wear over time. Secondly, issues with wiring, such as short circuits or damaged connectors between the TP sensors and the PCM, may disrupt the signal transmission, resulting in abnormal voltage outputs. Additionally, a malfunctioning PCM itself can cause these codes to trigger by failing to process the sensor data correctly. Each of these causes must be thoroughly examined to pinpoint the issue accurately. Proper diagnostics need to address both the sensors and their connections to ensure reliable operation of the throttle control system. The symptoms associated with DTC P0121 and P0221 can vary based on the severity of the issue. A common first indicator is the illumination of the check engine light on the dashboard, which serves as a warning to the driver that a fault has been detected. In more severe instances, drivers may experience reduced engine power, making it difficult to accelerate or maintain speed, an inherent safety concern. Erratic engine behavior, such as stalling or unexpected changes in engine RPM, can also occur due to data inconsistencies being sent to the PCM. Observing these symptoms is critical, as they highlight the necessity for immediate diagnostic attention to ensure not only the effective performance, but also to avoid potential hazards on the road. The first step in troubleshooting DTC P0121 and P0221 involves starting the vehicle's engine to establish its operating condition. After starting the engine, a comprehensive visual inspection of the throttle body and associated wiring should be completed. Look for any signs of wear, damage, or disconnections in the wiring harnesses leading to the TP sensors. Additionally, It is essential to use a diagnostic tool to check for any existing DTCs besides P0121 and P0221, as multiple codes may indicate broader issues affecting the throttle system. This preliminary step helps set the stage for more focused diagnostics by pinpointing any visible issues that might be prompting the error codes to trigger. In this second troubleshooting step, attention turns to the external circuit that interfaces with the throttle position sensors. Specifically, checking for short circuits in the THL1 and THL2 wires. To conduct this inspection, the PCM connector and the throttle body connectors must be detached. Care should be taken to ensure the connectors are handled gently to avoid damage. With the connectors removed, the next step is to measure the resistance of the THL1 and THL2 wires to ensure they are not shorted. A normal resistance reading should exceed 1 megaohm. If readings fall below this threshold, it indicates a short in the wiring, requiring repair or replacement. Comprehensive verification at this step is essential, as it can often reveal foundational wiring issues that lead to problematic sensor outputs. Once the external circuit inspection is complete, the third troubleshooting step involves assessing the TP sensor integrated within the throttle body assembly. The same precautions must be applied. Disconnecting the PCM connector before initiating any tests to prevent electrical shock or damage to the components. The inspection requires verifying that there is no continuity in the throttle body's internal circuit while it is powered off. A lack of continuity indicates that the sensor is functioning correctly and is not shorted internally. Conversely, if continuity does exist, this implies there is a failure within the throttle body that necessitates further attention or replacement. This inspection can often pinpoint directly whether the throttle body assembly needs servicing or replacement. In the final troubleshooting step, if both the TP sensor and external circuit show normal conditions, the focus shifts to the powertrain control module, PCM, itself. It's essential at this point to validate that all previous tests have indicated no abnormalities, confirming that the sensors and wiring are functioning as intended. If, after these assessments, everything appears normal, it is reasonable to conclude that the PCM could be the malfunctioning component causing the DTCs to trigger. A thorough inspection of the PCM, including its connections and functionality, is required. In some cases, a PCM reprogram or replacement may be warranted to resolve the issue, ensuring that proper communication with the throttle position sensors is restored. After completing necessary repairs or replacements based on the diagnostic findings, the final step involves verifying the effectiveness of the repairs. Start by clearing any DTCs from the PCM to reset the system. It is crucial to perform a test drive under various driving conditions to confirm that the repairs have resolved the issues associated with DTC P0121 and P0221. During the test drive, pay attention to how the vehicle responds. The throttle should operate smoothly without any indications of stalling or reduced power. If everything checks out and no new DTCs arise, it indicates that the repair was successful. Documenting the results of the verification step is equally important for future reference, or if the issue were to recur. To mitigate the recurrence of issues associated with DTC P0121 and P0221, it is vital to practice regular preventive maintenance. Consistent inspections of the throttle body and TP sensors can help identify any developing faults before they escalate. Maintaining cleanliness within the throttle body can prevent dirt buildup that could impact sensor performance. Additionally, monitoring DTCs periodically during routine vehicle checkups is a proactive way to catch problems early. Educating vehicle owners about the significance of these components can also encourage them to be vigilant regarding any unusual vehicle behavior. This proactive approach not only enhances vehicle reliability, but ultimately prolongs the engine's operational lifespan. In conclusion, understanding the significance of DTC P0121 and P0221 is essential for maintaining optimal engine performance in Honda Civics from 2022 onward. A thorough diagnostic process is critical to identify the root causes associated with these codes accurately. It is important to meticulously follow the outlined troubleshooting steps to avoid unnecessary part replacements. Additionally, performing regular maintenance and inspections of the throttle position sensors and associated components can mitigate future issues. Awareness and proactive measures can lead to a more dependable driving experience and enhance the life of the vehicle. By taking these steps, both technicians and vehicle owners can ensure that their cars operate efficiently and safely. Please like and subscribe to the channel. See you next time!